we have three parameters here. X, Y is, of course, the coordinate, and then lambda.
The lambda.
Lambda is the Lagrange multiplier. So what we have here, we write the function plus we have this lambda and we multiply it with some constant minus new function. New function is made from the constraint. When you put that constraint to 0, and you get, this is of course your objective function which is given to you.
Yeah.
And yeah, and like lambda is the multiplier, the Lagrange multiplier. And how do we get this k thing? Let's have this question.
K is a constant, ma'am.
Yeah, k is the constant. So if you can, there's one question, optimize. Oh, this cable is not working. Just give me a second. You have a question, 4x square plus 3xy. Are you jotting down?
Yes, ma'am. 4x square.
Plus 3xy
Huh.
plus 6y square.
Okay.
This is z, okay? You need to optimize it.
Huh.
And it is subject to the constraint, which is x plus y equals 56. Yeah, now it.
Got it, ma'am.
So z is given to you 4x square.
Got it.
Hmm.
I'll optimize.
Okay.
So general form. Ma'am, I'll optimize, right? And I'll tell you.
Huh.
Okay. xy plus 6y square plus lambda 36 zx equals 8x 3y as lambda zy equals x plus y as lambda z lambda equals 6 minus x minus y. So minus lambda is mm, 8x plus y minus lambda 3x plus 12y plus lambda 0 equals 0 minus plus 5x minus 9y equals 0. 5x equals 9y. X is equal to 1.8. 56 minus 1.89 minus 1. 6 minus Okay. Hmm. No. It. Ma'am, I got the values of lambda, x, and y.
Yeah, what are they?
Now, should I substitute it to the equation?
Yes, to the function, and then
These
you
are
will
these
get
are my critical values.
yes. So what are these which we got?
The critical values. Oh, also I got y as 20. I got first I got y, then I got x as 36, and lambda value as 348.
Perfect. And then you will be able to substitute it into this function. Yeah. And then that will be
Okay.
your value. If question has asked to minimize it, then that will be your minimum value. And if it is asking to maximize, it is the maximum value. Why I asked you this? Because I have seen a few questions totally on Lagrange multipliers, but in a different form. So if you can, let's start from the ninth one. Read it.
Okay. Consider the problem form of maximizing xyz subject to x plus y plus z less than or equal to 1. Oh, okay. X is greater than or equal to 0, y is greater than or equal to 0, and z is greater than or equal to 0. Obviously, the three-letter constraints do not bind, and we can concentrate only on the first constraint. X plus y plus z is less than or equal to 0. Okay. Or obviously, three
Yes.
latter constraints do not bind. Find the solution and Lagrange multiplier and show how the optimal value would change if instead the constant was changed to x plus y plus z is less than or equal to 9, is 0.9. So, okay, got it, ma'am.
So my
Ma'am, here xyz is a function.
your yes, maximize whichever thing is asked to maximize or minimize, that is your main function value or what we call objective function. Okay. And then the constraint is given. So you can say that it is C when at first you have to check it for 1 and then you have to check it for 9 over 10.
0.9. Hmm.
So you have to maximize it. So you need to see that out of these, which one is the maximum value. I mean, how it is changing. Is it decreasing or increasing? So how would you approach it?
Ma'am,
Now
we
this
follow the
line,
same process, right?
yeah. Do you get this line? The three letter constraints do not bind.
Uh, yes, ma'am, because ma'am, it could also bind. No, it could also bind. It can also not bind. What if
Give
what
me
if
an
x
instance.
plus
Hmm.
ma'am, what is x plus y plus 0 is 0.3, 0.3, 0.3.
Okay.
In that case, it is binding, and it could also not. Yeah, ma'am, it is binding. No.
So you have taken 0.3, 0.3, 0.3, but then we also need to see whether this is giving me the maximum value or not. Because if you consider that, see, if you consider this as equal sign, then if x, y, z becomes 0, any of them becomes 0, then the value is, the product is 0. And we don't consider, I mean, what this value states. We need either negative or positive values to state that whether it is giving me maximizing or minimizing value, right?
Yeah.
Yeah, that's why it is the line here given. So we need to find out firstly the
Ma'am,
solution
I
that,
still did not understand.
okay. Question is saying the three constraints x, y, and z, which are greater than or equal to 0. If you consider any of these values, uh, why are you taking all of them equal? Consider the values which are greater than 0, but they give you the value lesser than 1 or equal to 1. Consider different values when x, y, z not equal.
Ma'am, it could be point 0.1, point 0.2, point 0.3.
Can I say that if I consider, because it is asking me, it is not binding. So consider that value which is not binding. It is,
Okay, 1, 2, 3.
if you consider 1, but this has to be satisfied. Still, it has to be satisfied.
What, ma'am? What has to be, the constraint has to be satisfied.
No, this function, the value of sum has to be lesser than or equal to 1.
Ma'am, in that case, point 0.1, point 0.2, point 0.3 works, no?
If you consider this, or if I consider x as 0, then what y and z has to be? Maybe 0.2, 0.8. We need to think of that value which is not binding. Um, if I consider lesser value, let's say minus 0.1, and then y plus z has to be zero point 0.1 and then 1. Is this fine? Is the function is
Yeah,
satisfied
it
here?
is still binding. Yeah,
But then the line is also applies, is applying here, right? This line that later constraints do not bind, but we can concentrate only on the first constraint, which is giving me the answer. Is this fine?
yeah, ma'am. But then why do they say that it's obviously obvious that the three letter constraints do not bind?
They are saying that you can get this answer, the x plus y plus z can,
Oh, got it, got it, got it, got
even
it,
if
got
the
it, got it.
constraint is not here.
Oh, ma'am, so what they're saying is x plus y plus z is less than or equal to 0. You can concentrate
One.
on this and you can get that irrespective of the second constant because it doesn't really bind. So x, as you
Yes.
said, can be minus 0.1 also.
Yes.
But still the first country constraint is binding.
Yes.
Oh, got it, ma'am.
Okay. So now, if you can solve it and tell me what's the value of x, y. See, when it is asking me for the solution, that is the value of x, y, and Lagrange multiplier is lambda. Then you have to say that how it is changing. When you will substitute, I mean, you will find the value of x, y, and then the value of lambda. This is whole function, the value of x, y, z, and the value of lambda. How is it changing the function? How x, y, z, this product is changing when you are changing 1 to 9 by 10. Are you getting?
Got it, ma'am.
Yeah.
Ma'am, so we just do we sort of find the xyz and lambda values at both for both the constraints,
Hmm.
and then we just tell, right, this is how
Yes.
much the values of the xyz and the constraint has changed
Yeah.
and the lambda has changed.
Hmm.
Ma'am, so over here the general objective equation is going to be, for example, f equals
You have your Lagrange function, the optimization function
xyz
as
plus
the
lambda.
function plus lambda, right? This is the function
Yeah.
plus lambda.
1
Now
minus
you will,
x minus y
correct,
minus z.
correct.
Got it. So
Now you will
fx
do
is
the
going to be yz
partial
minus
derivative.
lambda. Fy is going to be xz minus lambda. F z is going to be x y minus lambda. Uh, F lambda is going to be 1 minus x minus y minus z.
Did you get these values?
Yes, ma'am.
So lambda has become what?
So
Why is
I'll
it?
solve for equations.
Hmm.
Lambda is become 1 minus x minus y minus z.
Now, how will you find the solution?
Ma'am, so far I'll solve remove lambda, so it's gonna be so y z minus lambda or x z minus lambda 0 0 y z minus x z z y minus ma'am, y equals x equals y in this case.
Correct. So if you substitute it in this, what will you get your XYZ?
Yeah. Ma'am, similarly, ma'am, in this case, x equals y equals z.
So if you substitute this in this equation, when you actually equate
Yeah.
the
3x
first,
equals 1. Or
so each value is 1 by 3.
x equals 1 by 3 equals y equals z. Yes, ma'am.
So now my function is,
Ma'am, lambda value we have to find now.
oh yes,
1 by 3. Ma'am, lambda is 1 by 9.
and the function is this. Now it is asking me to change it to 9 by 10. So of course, up till here,
Is the same. Yes. Ma'am, so एक ही change होगा.
hmm,
Ma'am, it's going to be zero point 0.9 by 3.
so now x plus y plus z equals 9 by 10, right? That is 0.9.
0.9.
So all of these are same.
So
So
it's x y z equals zero point 0.9 by 3, zero point 0.9 by 3, zero point 0.9 by 3.
correct. And hence, okay, firstly lambda, which is which is what? XY or
My
YZ?
lambda is going to be, yeah, point 0.81 divided by 9.
Why 0.81? अच्छा, ठीक है. Or we could have
This is my
taken the
lambda value.
lambda we got. Now the XYZ.
So
Tell me
x
what
y
is.
z is going to be, yeah, so 0 point 0.9 to 0.9. Ma'am, it's 0.027.
So tell me, this is 1 over 27. Is it decreasing or
Yeah.
increasing? You can use calculator.
Ma'am, it's 1 second. Ma'am, what are we trying to do here again?
Question
I did
is,
not understand.
question is, how the optimal value, that is the function's value, would change if the constraint changed to this. So how the optimal value changed, that means initially you were doing maximize XYZ and you got your maximum XYZ
Yeah.
as how much? Point Z. Why it's cut off? Oh yeah. So we got it as this point zero zero three three.
Yeah.
But now,
1 upon 27. XYZ initial constraint.
so that means it is only asking us to tell them the change, what is
We got
happening,
0.027.
which is lesser, right? So the optimal value decreases when
Yeah,
it
so the value of
becomes,
the function has come down.
yes, if we decreases the constant C from 1 to 9 by 10, the optimal value also decreasing. Is this fine?
Yes, ma'am. When
Perfect.
we reduce a constraint, the optimum value reduces as well.
Yes. Okay, so this
Hello?
was, I think, yes, I can hear you. Am I audible?
Yes, ma'am.
Okay, so now see, read this question.
Solve the following problem when A belongs to 1 upon 2, 3 upon 2, and max of x and y greater than or equal to 0. X square plus y square subject to ax plus y equals 1.
Now see, this question has not asked to use Lagrange multipliers, but it is still saying maximize. So we need to find out the
Yeah.
arbitrary constant also within the limit. So whenever it is optimization question, so first of all, write down the function which is x square plus y square, the constraint which is x is greater than 0, y is greater than or equal to 0, and ax plus y equals 1, right?
0 and ax plus y. Yes, ma'am.
So this is the question. Now what can I do? It is y square, right? Hmm. I need to solve it for xy. If I have two equation, let's try substitution, doing it from one way to another. So y will become from here 1 minus ax. Now because y is greater than 0, greater than or equal to 0. So this 1 minus ax has to be greater than or equal to 0, right?
1 second, ma'am. So y is greater than or equal to 0. Therefore, 1 minus. Yeah.
So what is the value of a from here or x from here?
Ma'am, it's going to be 3 upon 2.
3 upon 2. Value of x.
Oh, from here. So it's going to be, ma'am, x is less than or equal to 1 upon a.
And we know though x is lesser than or equal to 1 by from here, but still x has to be greater than or equal to 0, right?
Yeah.
So what is the least value of x? from both of them.
Greater than or equal to x is less than or equal to 1 upon a, where
X is greater than or equal to 0 but less than or equal to 1 by a. So what is the
a.
least value of x?
Hmm.
0, right?
A.
I have combined these two inequalities. So this is what I've got. So the least value of x is 0 and maximum value is 1 by a, right?
Yeah.
So the limit which I got for x is 0 to 1 by a. Now if I substitute, because I need to find out the solution, that is x and y. I got my x. How? Because I already know what is my a. Because a lying from 1 by 2 to 3 by 2 closed interval. So that means x is there. What about y now? So substitute this value. See here, we have the function x square plus y square, right?
Yeah.
And y is what from the constraint? 1
Y
minus
is
a.
1 minus a.
So if I solve it further, a minus b whole square, a square plus b square minus 2ab. These two I can take x square common. So this will become what? 1 plus a square. And then I have minus 2x plus 1, right?
Yeah.
Now that means, so this is x square plus y square. So again, I'm reiterating the question. I need to maximize x square plus y square. That means I need to maximize this value, right? Right?
Hmm.
And in order to maximize, I need to see that x is already defined, which is from
0
0
to
to 1 by.
plus 1 by a.
Now tell me, can you, only by looking at the equation, can you tell me, of course it is a quadratic equation, so it will give me graphically a parabola. Can you tell me whether it is an upward, it is going to be upward parabola or downward parabola? It depends on which factor.
Ma'am, the sign of a.
Correct. So this is 1 plus a square, right?
Yeah.
Coefficient of x square. Now I know if it is positive, because it is lying in between 1 plus a square, if parabola is opening upwards, right?
Yeah.
Biggest value, the maximum value which it can give me will be where? At the endpoints or at the vertex? Maximum value.
Ma'am, at the vertex, ma'am.
Maximum value of upward parabola.
Oh, upward parabola is. Ma'am, upward parabola is. Ma'am, it's going to be vertex, no? Not the.
Upward means increasing, convex. It will give you minimum and then it is
Oh, then
increasing
then
here.
the endpoints.
Yeah. Maximum value of upward parabola is at endpoints. And endpoints has x and y as what? I mean, x values as 0 and 1 by.
A. Yeah.
So I need to check what it will give me as y if I substitute here x 0 and x 1 by a. So if I first substitute,
0. It's gonna be 1, ma'am.
what is it? X square plus y square. It is, what is giving you? 1. Okay. At x 1 by a,
Ma'am, so it's an equation I'll solve. 1 upon a square. Okay. Ma'am, so it gives me 1 plus a square divided by a square minus 3.
okay, let's try x square into, I'm putting 0, no, 1 by a, right? So
1
1
by
by
a.
a square, 1 plus a square minus 2a, 1 by a plus 1. A is cancelled, and then it has become 1 plus a square if I multiply it 1 by 1, and then a square by a square, that is 1.
1,
So 2
1,
minus 2 is 0. 1 by a
0.
square,
Oh,
right?
yeah. Ma'am. Yeah. 1 by a
So
square. Yep, yep.
now that means my y lies from 0 to,
1 to
oh, 1 tha. Oh, yes.
1 thumb. 1 to 1 by a square.
A square. Now again back to question. I have got my endpoints. When I'm substituting x as 0, I'm getting 1. And when I'm substituting 1 by, I'm getting 1 by a square. I got my values, but still I need to see which one is giving me maxima, right? It is an endpoint,
Yeah.
of course, and I need to maximize the function to
Ma'am, where
solve
did we get 0, comma 1 here, ma'am?
uh, at x 0. When we substitute x 0,
Oh,
what
then
we'll
y
get?
is 1. Yes, yes. Ma'am, there are two. Okay, got it, got it. Near to
Now,
endpoints. Yes.
yeah. So this is very clear. If I substitute x square plus y square, this is 0 square plus 1 square, which is 1. Now for 1 by a plus 1, I mean 1 by a and 1 by a square, I need to check which one is giving me that value. For example, if I have a lesser than 1,
Ma'am, so we want to check what value of a if we substitute in x square plus y square is going to give us a value of y which is 1 upon a square.
yes, we want to check because a is also has the limit. It's lying between 1 by 2 and
Yeah,
3 by.
a
So
lies between 1 by 2 to 3 by 2. Yep.
that is this one. So it has lesser values also and greater than values also. So if I say if a is less than 1, then the value of y, which is 1 by a square, will it be less than 1 or greater than 1?
If a is less than 1, then 1 by a is less than 1, then value of uh,
The smaller the denominator,
uh, the the larger the fraction.
correct. So if you consider zero point 0.6 whole square, it will give you way bigger values, right?
Yeah,
So it is greater than.
greater
If
than
I
1.
have a greater than 1, then I'll get a square less than 1. And if I have a exactly 1, then 1 by 1 square, that is 1, right?
Hmm.
So these are my y values. What do you think? Which one is giving you the maximum? Greater than 1 is also constrained to that limit of a, which is not more than
Ma'am, one
1.5.
second, ma'am. The last three steps I did not understand.
So I was trying to define the a because a is a continuous interval lying from 1 by 2 to 3 by 2. So I need to
Hmm.
check. It will be having various values from decreasing to increasing, all sort of values it will give me, right? It is having
Yeah.
0.5, it has 1 also in between, it has 1.5, right?
Yes.
So I'm trying to see if it is lesser than 1, greater than 1, or equal to 1, then what is the value which I'm getting for 1 by a square, that is y. Does this make sense or not?
Yeah.
So once I get these values, I want to see, my purpose is to maximize x square plus y square. From first value 0, comma 1, I got this x square plus y square. But when it is
मैम over here maximizing का मतलब क्या होगा मैम? With the
maximizing
x square plus.
means whichever value, I mean the set of values which you are getting for x and y, x1, y1, x2, y2, when you are substituting these values into the function, which one is giving you the maximum?
The highest value of a function, of the
Yes,
function.
yes. We are checking for local local maxima for the neighborhood.
Okay.
Yeah.
समझा.
So bus you will write that if you get a equals 1, then it is 1. Otherwise, these are giving you lesser or greater than value. So x square plus y square will become what? Your x is 1 by a, your y is 1 by a square.
The whole square.
So the function is 1 by a square upon
A
1
square
by
plus
a
1 by
whole.
the a.
Yeah. So this is my, what's LCM? A square plus 1.
Hmm.
So this is the function. Now I'll
Function.
substitute various values of a from 1 by 2 to 3 by 2, right?
Yeah.
And you will see that the maximum is this. 1 is the maximum. Because you can see that it is having greater denominators. The maximum value of a is what? 1.
One.
The maximum is 1.5, but it will also not give you what? This, if you put
Ma'am,
down 1,
how? Oh, yeah, yeah, yeah. Because we have higher denominators.
yes. So the maximum is if you get a as 1, so that will give you 2 as the maximum value for the function if you keep a 1. Otherwise, it will give you lesser values, and then this 0, comma 1 will be your maximize x square plus y square. Is this fine?
Yes, समझा.
तो ये थोड़ा Lagrange पर ही था, but this was a variant.
Yeah, we didn't use Lagrange here.
Yeah. Read it. Next question. It is again the similar to what we did in the last one.
Solve the following problem. Maximize x1, x2. Ma'am, how do you read this? Maximize x1, x2?
Yeah, maximize
The
x1. Hmm.
function
Which,
x1 square x2 subject to x1 2x1 the whole square plus x2 the whole square equals 3.
yeah, so these are the constraints given to us. Usually they write, when they write here x1, x2, they are bound to give us the constraint, but it is not given here. So let it be. So you have to solve for x1 for the function, but need to find out x1, x2 such that they'll satisfy this equation. What's happening?
Ma'am,
Is
question.
uh
Why don't we use Lagrange here, ma'am? Why don't we go through the Lagrange way?
okay, I'll tell you. Okay, let's do Lagrange here. You cannot apply this is the first condition for Lagrange multiplier. You will find one question where you need to check. You need to solve this using the traditional, and then you need to compare the solution with Lagrange, and then you will say that Lagrange does not apply here. You know why? Because for Lagrange, the first order derivative has to be zero, right? You need to
Yeah,
equate
it
it to
must be
zero.
equal to 0.
So if you will find that because of rest of the constraints, if you substitute, there is no way to get it zero. Then you will say that it doesn't apply.
No,
We'll come
ma'am.
to that question also. So let's do, you can do, of course, for max optimization, we have been talking about optimization, and one of the solutions are this Lagrange also. One of the
Yeah.
solutions is Lagrange also, so you need to check whether it is um, its conditions are applied or not. Let's say. So we have, don't write the conventional thing that Lagrange for xy. Whatever variables are given to you, you need to use them. So x1, x2, and lambda, that will give you what? Firstly, what you write?
Ma'am, so it's going to be x1 the whole square into x2 plus lambda 3 minus 2x1 square plus x2 the whole square.
Y plus?
Sorry,
Acha,
minus x2.
maybe
Sorry.
you are giving it in the bracket. So later you have to distribute the minus sign. So what is the first derivative?
My first derivative, if fx1 is going to be, yeah, 2x1 x2
Hmm.
um, minus, yeah, it's going to be minus 2 lambda.
2 lambda.
Oh, x1 square. Sorry. Ma'am, it's going to be, yeah, minus 4
Hmm.
lambda x1.
So, right.
Yeah,
So what is, this is 2x1, x2 equals 4 lambda x1. X1 gone, 2 ones are 2, 2 to the 4. X2 is 2 lambda. Then
oh, got it.
del
And then
x.
lx2
Hmm.
equals x1 the whole square
Hmm.
minus lambda
So you don't call it x1 the whole square. It is, when it is
x1
subscript,
square.
it is x1 square only, right?
Yeah,
Huh. So x1 square then,
x1 square minus lambda.
hmm, just lambda.
And yeah, ma'am. Oh, no. Sorry. Array, silly. 2x2
So 2 lambda x2. We need to
lambda x2
substitute it to 0.
equals
Now
0.
x 2
X
lambda x.
x1 square equals 2 lambda x2.
What is x2 from here?
X1 equals root of 2 lambda x2.
But I can substitute this value, right? In
X2,
place of
yeah,
x2.
2 lambda into 2 lambda.
So x1 has
X1
become
equals x1 equals 2 lambda
plus minus 2.
plus minus 2 lambda.
Now, because x2 is also 2 lambda, so can I say that from that and this one, x1 is equal to plus minus x2? Because,
Yeah,
yeah. Now you substitute these two in the constraint, which is 2x1 square plus x2 square equals 3. So
there
if
are
you
two equations.
substitute, you have two cases to follow. So if your x1 and x1 is equal to plus x2, and
Hmm.
1 when x1 is equal to minus x2.
Minus x2.
So what is here the value?
Mhm. So yeah, so one is gonna be 3x1 square
Hmm.
equals 3. X1 equals so plus or minus 1.
So that means x2 is also plus or
X2 is
minus.
also plus or minus 1.
So 1, 1 and minus 1 are my values. And I need to find out the function for these values, right?
Yeah,
At 1, 1, my function, which is x1 square x2,
1
is 1. And from here,
minus 1.
so we've got, I need to check for which one I am getting maximize function. So I've got
I'm
two
focusing, yeah.
functions. I have to find out two more values now from case 2, right?
Oh yeah,
Hmm. So if you substitute this, what you'll get? It will not affect, right? Because it is square. So it will give you same value for
same value.
x1.
Yeah, minus
But
plus minus 1.
if you take x1 as plus minus 1, then x2 will become minus plus 1.
Minus plus 1.
So that means you have one value as 1 minus 1.
1 minus 1 and minus 1 1.
So what's the function? X1 square x2.
Ma'am, the first one is gonna be minus 1, the second one is gonna be 1.
So pretty easy. I mean, I can check which one is giving me the maximum value. Maximum value for the function is
Ma'am,
1.
second one, 1.
And it is giving me at 2 points.
1 comma
1,
1
1,
and this 1 comma 1.
minus 1. Right?
Yes.
So this is how we solve it. So Lagrange also works sometimes.
Ma'am,
I'll give you the
how do we
exception.
solve another way?
Huh?
अदर वे में कैसे सॉल्व करते हैं द
Other
वन
way के लिए, other way के लिए, I must be having more than one constraint, just like we have been doing here. Right?
what does the other one more? Oh, the okay. So the first constraint is ax plus y equals 1, and the second constraint is a belongs to
Yes.
a
1 by
ranges
2.
from 1 by 2 to 3 by 2.
Right? Otherwise, I'll not be able to have those two equations to solve for two variables. Right?
Yes, ma'am, got it.
And here, question had not asked me to find out Lagrange multiplier. So if you do it, it is a plus. But because it has not asked me, so without it also I could have solved my maximum value. I mean, at the moment, what I've got is the function, the optimizing value of x1 square and x2. Now, because I have used Lagrange, so my optimum value for what was x1, x2? For maximum, 1, 1 and
Ma'am,
minus 1.
minus 1 comma 1 and 1 comma 1.
So now you need lambda, right? Because you will substitute your function here, the maximum value of function.
Yeah.
Clear?
नहीं मैम नॉट क्लियर
Right?
समझ नहीं आया.
Acha. So why do we use Lagrange multiplier? to get the optimization value, right?
Yeah.
So this new function is giving me the maximum when lambda is given and the points are given. More optimized maximum, right? Considering
Okay.
the constraint also. So this is the whole function which I have to use, right? x1 square, x2 plus lambda. I need to put in the values. The first question which we did in the beginning of this class, today's class, you substituted the value into LZ, right? I mean, you were
Yeah.
supposed to.
Yeah.
So at last you had to give it a try, and then you need to see which one out of these two is also best, is also the best option when I'm saying maximize. Are you getting my
Ma'am, but
point?
in this case, both of them are giving the same values.
Same values, and you will say both of them are there. It is square, square. Yeah, it will not affect. But sometimes it may affect if linear powers are there. Okay? But the
Hmm.
function's value will be different when you will substitute here because of lambda. It is the function's value when I'm combining the function, this one, with what? The constraint of 2x squared, 2x1 square plus x2 equals to. Clear?
Yeah.
Moving on to the next one. Oh, what will do? Maximize only x, subject to x plus x cube plus y square. Um, let's try and see where it takes.
ठीक है. Do Lagrange.
And Lagrange will come because it is the second part. So let's try with the first one first. My function is just x,
Yeah.
and the condition is, let's see, can we
X.
find anything from here? I can't do it without constraints, so I need to bring out the constraint from this, if I can do. First task
You
is to
take.
find out the constraint also. Let's see how we can do. If you see, analyze this constraint, it can lead you to another constraint. How? You see, y square is minus x cube from here, right?
Hmm.
And you know that y square of anything is always greater than or equal to 0 for every,
Yeah.
if y is there for
Why?
any number.
Yes, ma'am.
And if the result is greater than or equal to 0, this value is also, I mean, it has to greater than or equal to 0, right? If it has to be equated to y square, so y square's condition has to be followed if it is equal. And if it is equal, because equal is given to us, right?
Ma'am, I'm sorry, ma'am. I lost you.
Acha.
Can you repeat?
Huh. So from here, which is the proven fact, I mean, it is true, that's why it is given to us. So I have got this one, or I could say this one, from this constraint only, right?
Yeah.
Now I know if you are squaring something, the left side is also always going to give me greater than or equal to
Positive.
0 values.
Yes.
So how come this is possible that left side is positive and right side is negative? Both of them have to be positive, right?
Yeah.
But how can I find that value? That is only possible if I substitute x as negative. Then
X as negative. Yes.
negative power is positive, and sorry, negative power is
And
negative, and then negative
ne-
positive, right?
negative, positive. Yes.
So from here, that means right hand side has to be greater than or equal to 0. So that means x cube has to be
Is
lesser than
less
or
than or
equal to
equal to
0.
0.
That means x has to be lesser than or equal to 0.
Less than or
So
equal
this
to 0.
is the
Yes, ma'am.
constraint which I have got. That
Okay.
if you express this in terms of y, you will see that because y square is minus x cube. And y
Yeah,
has to be, I mean, it's just the exaggeration of question.
plus or
You know,
minus
this
x
can
cube.
only
Yes.
be possible only in that
On
case when
x.
x is 0 and y is 0. No other case. Think of it.
Hmm. What about
Minus
negative
1.
1, ma'am? Yeah.
Um, see. But then y will also become what? But y can be plus minus 1, no?
Oh, no, but then y has to be greater than or equal to
Yeah.
1.
So this is the only case.
Yes.
So I have got my constraint now. Now I need to rephrase the question, which is maximizing x at x0, y0 for x, subject to that x cube plus y square equals 0, right? So that
Yeah.
means if I substitute any value, the maximum value for this case will be 0, 0 only, right? Because you think of any larger value of x here, you will not get positive y.
Hmm. Yes.
So this is the only solution which I have got.
0, comma 0. Oh, damn. This is insane.
So because the function was asked, so x value has to be the answer, that is 0. Okay. Now
Bapi
question is also asking, is the
is
Lagrange
Lagrange.
approach appropriate?
Ah,
Hmm.
this Purush.
So that means I have x, y, and lambda. I'll substitute the function, which is x only, and then
0
what?
minus x cube minus y square. So it's going to be fx equals 1 minus 3x square, where 3x square
Lambda.
equals 1. Yeah, lambda equals minus 3 minus x square. No, minus x cube minus y square.
Why are you considering x
Yeah.
cube here? It is partial
I was
derivative with
doing for
respect to.
lambda. I was doing for lambda, ma'am.
अच्छा अच्छा.
हाँ y तो it's ये minus 2y minus lambda 2y.
And then,
Ma'am, for lambda it's going to be minus x cube minus y square.
right. So tell me, if you substitute x, y 0, because you will see y is 0 from here.
Yeah.
And then what is your lambda? If you do it with respect to lambda, what is it? Minus x
Ma'am,
cube
so
minus
lambda
y
is
square.
yeah.
And from here, what is lambda? So if y is 0, from here lambda is also 0. So x is 0. Everything is 0.
Ma'am, fx is not 0, right? Over there, you can get, no?
Uh, if you have from here, see, if your y is 0, of course you will say that lambda will be 1 by 3x square. But
Yeah.
you see, if y is 0 from here, lambda will also be 0 from here, right?
Huh.
So lambda 0, so x is also 0. Yes or no?
Yeah.
Now tell me one thing. If everything is 0, x, y, 0, then the gradient dy by dx, there is no change. Lagrange can only be multiplied. There is a change in the gradient. There's the
No,
condition
what is the
that your
gradient?
gradient is slope.
Okay, okay,
You cannot I mean, must be a change. Then only you can put in optimization. Then only you will be able to compare which one is greater, which one is smaller. If both of them are 0, how can you compare? So Lagrange method is not valid here because the constraint qualification, which is that x and y cannot be 0. You must have seen that always in the Lagrange something like this is given. So both of them cannot be 0 for Lagrange to
okay.
be applied. Okay?
Got it, ma'am. Noted. 1 second, ma'am.
Yeah.
Got it, ma'am.
Okay. Now you want 5 minutes break?
Yes, just 5 minutes.
Okay.
Back, ma'am.
See, what is it required to solve this?
Okay, solve the following problem. Maximize min of xy minus x square minus y square.
So this is the combination of optimization. Min of max. Sorry, max of min.
So you maximize the minimum of these two.
Yeah. So firstly, you will solve it as per BODMAS. Firstly, brackets, and then you will come out to prove that bracket as maximum. Okay. So,
Whoa.
hmm. So basically, this is the constraint. I mean, minimum of xy has to be there and minus x square minus y square. Agar, if you see, minimum of xy minus x square minus y square is given. So I need to assume, if you see by symmetry, if any symmetry is possible, then only we can assume that maxima and minima is there. And for that,
Now,
x
what's the
has,
symmetry in this case?
whenever we have a parabola, this is the line of symmetry,
Oh, minus b upon 2.
which
Yes.
through which this vertex passes. Okay.
Hmm.
So what is it? This you have to assume that if you if you want to have, you can see that x square, y square are given as the main function's highest power. So this is a parabolic function, right? This is a
Yeah.
parabolic function. Now, if you can't assume it, then let's do it other way. Minimum of xy is required. So for that, you need to assume that which one is minimum of x and y, right? Because nothing is given. Either you assume that y is minimum, I mean y is lesser than x, or you assume that x is lesser than y. Then only you will be able to get that minimum of xy is x actually, right? If I have 2 comma 3, minimum of 2 comma 3 is 2. But for that, I
Yeah.
need to know which one is, if it is arbitrary, I need to know which one is lesser. Without that condition, I would not be able to solve it. So you need to assume that, let's say x is lesser than or equal
Ma'am,
to.
one question. So over here, when we say minimum, we mean that in a on a particular point on a coordinate which is x comma y,
Yeah.
the smaller value between x comma y is either the minimum and the larger value of x comma y is the maximum.
It is not the coordinate. This is the set. Which value you are going to get
It's an
of.
ordered. pair, right?
It is a set, yes. It is not ordered pair. For this particular, you can see the curly braces are given, so we can't assume that this is an ordered pair. Okay?
Okay.
It is like as we used to write in concave convex, minimum of FA. Did you get it?
No, ma'am.
Okay, we had this A belongs to 1 by 2 and 3 by 2.
Yeah.
So if I have to find out which one is minima of this is xy. So I'll find out the function and then so that doesn't mean that these are coordinate, right?
No.
Does it make sense or not?
Yes, yes. No, no, understood, no.
Okay. So I need to have this. So this is like, you can see we have another variant of the question when we are assuming ourselves that what will be the condition because minima is given. Minima for a set we have to find out in order to optimize this. Of course, I can't do it for maxima, which is the main optimization question constraint, because then it is like you are imposing yourself on it. But when it is in the braces, something is given, then you can assume the condition. You need to have those conditions which through which you can solve this bracket. Okay, is this fine?
Hmm. Yeah.
So if my minima of xy is x, now my question has been transformed. My question is now maxima of xy, minima of xy, I have found out x minus x square minus y square. Is it
Ma'am,
fine?
we found out x because we are assuming that x is less than or
Correct.
equal to y.
Correct.
Ma'am,
So
but
that
then why are we assuming that y is less than or equal to x?
you can assume that also. You are just assuming because you need to consider the constraint. You can write, let's assume x is lesser than or equal to y. It might be the case that y is lesser than or equal to x because constraint is not given and we need to find out the minima. So we have to assume. Or you can elaborate it using case 1 and case 2. So I'm explaining
Okay.
one of the cases. You do it from homework, the second part, and see
Okay.
what it brings on the table. Okay.
Okay.
So this is maximum of xy for this. So now the question is this and the constraint is this. Is this fine? My question is right. I have changed
Hmm.
it because of the constraint. This is right. If it would have been y is lesser than x, I could have written y minus x
Y
square minus
minus
y
x square minus y square.
square, right?
Got it.
Now,
So now we maximize
now,
x minus x.
yes, if I know that I have a fixed value of x for which x is lesser than or equal to y. So what will be the least value of y then?
X.
Correct. But as you see in this expression, what is happening? It is minus y square which is given in the expression. So that
Yeah.
means if you will increase y, this will decreases, this will decrease, right? It is getting
Yes.
decreased as y gets increased.
Increased. Yeah.
So if you have to maximize the function,
You have to increase the value. Fine.
because you can't
No, no.
increase the value of y, so you need to consider that which one is the greatest. So which one is the
Yeah.
greatest value? Y equals x, right?
Yeah.
Y will be greater. Y will be the greatest if its value is the least because you are having minus y square in place, right?
Yeah.
So again, this constraint also we have to analyze and put into the question, introduce into the answer. Okay.
Okay.
So I've got firstly x is red. lesser than or equal to y, and then now y is y is equal to x. So now my function has become maximum of, I mean, this was the function initially, minus x. So this has now become maximum of
Maximum of my x minus x square minus y square.
y square, and x is equal to y
X is
now.
equal to y. So x square minus x. So 2x minus 2x square.
Oh, where has it gone? Question number
6. नहीं. हाँ.
this one. Okay.
Yeah.
So this has become maximum of,
Maximum of x minus 2x square.
tell me which which sort of parabola is it? Upwards, downwards?
Downwards. A is minus 2.
Correct. So because it is downward sloping, so tell me where will it be having its maxima?
End points.
Vertex, downward,
Oh,
maximum value.
downward sloping is the vertex. Upward is the end points. Yes, ma'am.
So maxima at vertex, and vertex formula is,
Minus p upon 2.
so what is the coefficient if you compare it
Ma'am,
with the standard?
so it's gonna be minus 1 divided by 2 divided by 4.
Right?
Yeah.
So this is my value of x. So the value for the function will be
2x square 2. Okay, yes, ma'am. 1 divided by 4. Yes.
minus 2x
No, one
square.
second.
हाँ बोलो.
ओ ओके ओके ओके, ये हम लोग फंक्शन में सब्स्टिट्यूट कर रहे हैं
Yes.
बिकॉज वी मैक्सिमाइजिंग.
Is this fine?
हाँ.
So this is how Lagrange you knew, but this is how you can set this up for the level of questions you are getting in your question paper.
बाप रे बाप.
This is the one which is for Hessian. So
ओके.
what is your homework for today? You need to
हाँ.
go through all the Lagrange questions, whatever. So I have covered only one problem set. It was on easy something, some year question paper was there, which you have
ओके.
given me. So you see what all varieties are there and try to solve them, and ask if you have any doubt. Okay.
ओके मैम.
Now this one, read it.
Let s ma'am, that's not a belongs to sign, no?
Subset.
Okay.
Subset of R raised by n.
Yeah, this is s subset to r is to n, the real number, be an open set, and a function that goes from uh, a S to R, that is the domain to the range, the be twice continuously differentiable function. Be twice continuously differentiable function. What is continuously differentiable, ma'am? Not partial.
Continuous, yeah, continuously differentiable. That means it is continuous as well as differentiable. That is left hand derivative is equal to right hand derivative, and left hand limit is equal to right hand limit. The graph which you can draw without, lifting the pencil.
Okay,
There should be no break.
got it.
Yeah,
So that is
so,
continuous.
yes.
Suppose that the derivative of fx
Hmm.
equals 0. State the weakest sufficient conditions that the Hessian must satisfy at the critical point x star for X star to be a local max, X star to be a strict local min.
So we talked about local minima and local maxima and gave you a few questions. I only took
Yeah.
uh, first part and rest of the things I gave you from homework. Did you try?
The ln and yes, ma'am. But then they were just simple proving.
No, for this one, B and C, global
Oh no,
maxima
no,
and
this I'll do, ma'am, today.
minima. Okay. So this is the extension of that question in which you need to write only theory. No question is given as such, but still you have to find out that condition which is required using Hessian to prove that that particular point, that critical point is having local maxima or local minima. Okay. So how to approach these? Of course, we'll use theory. Firstly, I have told you that whenever this sort of question is given, explain the key terms. So Hessian's condition is required. We know that for Hessian is a matrix of second derivative, second order
Yeah.
derivative. And because critical point is given x star, so what we'll do with critical point? We'll substitute its differentiation to 0 in order to
Hmm.
find out what's the value.
Critical point. Yes.
Then the condition which are asked. So we know that if that x star has to be local maxima, maxima is concave.
Yeah.
So it has to be
It has to be negative definite for
right.
Hessian. Yes.
If it is a non-zero, non-zero vector. And either you can find out now, explain how can you find out negative definite thing. Either you can say that it is about uh, that quadratic form. You are taking Hessian x less than 0, right? Transpose, and matrix. I mean, column vector, it's transpose and Hessian
For
quadratic
that,
form,
yeah,
lesser
quadratic
than or
form.
equal to 0. Also,
Ma'am,
you
what
can,
is the non-zero vector here?
okay, so it has asked me the weakest sufficient condition. So I could have used semi-definite thing also, but I'm just asked, the sufficient condition which has to be there. For semi-definiteness, it has to include 0. And if you are saying negative definite, because see, weakest sufficient means already it is saying that your differentiation you are substituting to 0. It is given. So the
Yeah,
most, the fully sufficient condition will be if your differentiation is 0, that means you are substituting x as 0. This is the sure event which anybody can have from the function which is continuously differentiable, because this is the limit you have. If x is equal to a, you find out upper limit and lower limit, but at this point you are going to get that particular function. So if you are going to check the sufficient condition for any other point, that is the weakest sufficient condition, for which it is definitely going to be local maxima or minima, then what you can suppose? A non-zero vector, which is not 0, and it is giving you a direction. And in that direction, you are finding out the sufficient condition. Did not get it?
ma'am, I understood until x is greater than a or x is less than a.
Hmm.
And the x is equal to a is a strong sufficient condition.
Correct. So I need to
After that,
find
I
it
don't
out
know.
for the weaker sufficient condition. That's why I'm using non-zero, not equal to 0.
Okay.
So my A is 0 here.
Okay.
So you could have used this quadratic form You could have taken the correspondence theorem and state that because the function is giving me hilltop, if function is not given here, if the function is giving us the hilltop and that is satisfying that linear combination thing greater than or equal to, then it is giving you negative definite, right? Or
Yeah.
concave. Or what you could have done about the eigenvalues, you could have said that check all the eigenvalues of your Hessian matrix. If it gives you for that, because function is not given, how to check? So you can just give the hint that if your double derivative of f is less than 0, your determinant is less than 0, then also you'll get the negative eigenvalues. And that means you are elaborating. Are you getting my point? Because there is no such thing. Either you could do it using a counter example, but that's not the traditional thing which your book is doing. So you have to explain using the statements and tell all the cases which can be there. Is this fine? This is
Yes,
for
ma'am.
local maxima.
Ma'am,
And when it,
since we're finding local maxima here,
hmm,
we'd want to consider a condition where my Hessian, where
hmm,
would want to consider the function through the Hessian, where
hmm,
it is negative definite,
hmm,
and
correct.
that's how we are going to define the function where where the quadratic form of the function is less than zero, thus the negative
Yes.
definite, it is thus it is
Local maxima.
sufficient for us to find a local maxima.
Yes. Is this
Got
clear?
it. Yes.
What about the second part, which is strict local minima? So for local minima, you have to converse it. Say it the graph of the function will be ball bottom, or you will say that positive definite thing will be there, or you could have said all eigenvalues are positive. Okay, is this fine, Purajit?
Yes, ma'am.
Okay. There is one sort of question which I found using, I mean, Lagrange has now been mixed with concave and convex thing. So this is another variant. Read it.
बाप रे मैम थोड़ा ज्यादा हो गया
ओके अगर ये ज्यादा हो गया तो लेग्रांज बाद में करते हैं कॉरेस्पॉन्डेंस थ्योरम कर लेते हैं
correspondence we did no ma'am that day.
हाँ मतलब उस पर बेस क्वेश्चन कर
Correspondence.
लुक एट दिस इज अगेन दे हैव टैग्ड इट हार्डर दिस इज योर क्वेश्चंस नोट व्हाट इज इट सेटिंग
Okay, show that any continuously differentiable function
हम्म
f such that the function going from real number to real number. Ma'am, here it means the domain to my range, both are real numbers, is it?
या इट इज डोमेन दिस इज कोडोमेन range is actual values of y which you are going to get by putting your domain values.
Ma'am, what is codomain?
So let's say I have 1, 2, 3 here, and my fx is x square. But I have considered natural number to natural number as my set. So it will be having starting from 1 various numbers. And here you will be having starting from 1 various numbers. But you know that 1 will be combined with 1. Because when you substitute 1, it will be 1 square 1. 2 will be combined with 4. 2 square is 4.
Yeah.
And 3 will be combined with 9. So my codomain is whole n. But when I'll be writing the relation, it will be 1, 1, 2, 4, 3, 9, something like that. So my codomain, my range is 1, 4, 9, and so on. not
Yeah.
whole B set. Okay,
Ma'am,
is
so
this
over
fine?
here the codomain is
Hmm.
1, 2. What is my codomain in this case?
Function is moving from I mean, the relation is moving from natural numbers to natural numbers. So codomain is the set of whole natural numbers, all natural numbers.
Ma'am, I don't, I'm not able to understand what do we mean here when the function moves from n to n.
Okay, I have 1, 2, 3. Here I
Yeah.
have again 1, 2, 3. So
I
my
mean, we have
relation
seen
is
this in all the questions, but then,
hmm. देखो, this is the relation from the arrow diagram which I've got. It is moving
yeah,
from A to B, where X belongs to A and ordered pair Y belongs to B. Is this fine?
that's my range.
So, no, my domain is the
A.
set of X elements in R.
Yeah,
My range is Y elements in R. But my codomain is the second set to which it is leading, the relation is leading to. That is, if relation is defined from A to B, that means always X from A, Y from B. So I'll write that B is the whole set B, that is 1, 2, 3, whatever is given, is my codomain. But you can see the answer of the function, the Y values are 1, 2 only. So this is my range.
A. Oh, got it.
Sometimes, sometimes range can be equal to codomain also, but not always. We have to define it separately. Is this fine?
Got it. Uh, Function moving from domain to codomain, satisfying, both of which are real numbers, satisfying. Uh, X, the differentiation of fx with respect to x less than or equal to 0 must be quasi-concave.
Now, not only function, its derivative is asked to be proved as quasi-concave. So as I told you, if you don't know how to approach it, you explain the condition for quasi-concavity. And then if you can consider that function which is quasi-concave as a counterexample and find out its derivative. This is one way of doing it. For example, consider fx as minus modulus x. Tell me whether it is quasi-concave or not. Did you revise those steps to prove? So if I'm assuming a counter example that my fx is minus of modulus x, okay? Right?
Yeah,
Now what you'll see, you'll check it. What are the possibilities of these values? You can see that if you substitute anything which is, I mean, the value of x, if you
less than
substitute
0.
lesser than 0, your f dash x will be what?
It'll
Because you need
be,
to find out this one, no? So your differentiation, Khurshid, am I audible?
yeah, ma'am. So we are the differentiation of x.
Yeah. So what it will be based on the function given minus modulus x. Okay, let me rephrase it. If I am having a value of x lesser than 0, let's say minus 1. So
Hmm.
after applying that absolute value, it will give me positive. but negative is outside.
Yeah.
So this will be -1.
Yeah.
Now this x f dash x will be,
Ma'am, but then that's not differentiation, right? That's we're just putting the value of x in the fx.
no, what I did, differentiation of x is 1, no? That's why I wrote here -1.
Oh, okay. Okay, samjha, samjha. Got it, got it.
X f dash x will be what? If you multiply
Minus x
x with this value, you will get what?
minus x.
-x. Now, because you have considered your x as lesser than 0, then this value -x will be greater than 0, right?
Yeah, yeah.
So that means this is greater than 0. It can be greater than or equal to also. If here you apply equal to, right? If you take this as equal to, then you can apply equal to here. Okay, what about if you take x greater than 0, greater than or equal to? Your f dash x will
Ma'am,
be
so again, f dash x is going to be -1.
-1. And what about x f dash x?
Ma'am, again, say minus x.
Okay. Now, what will happen if you have -x? The value for x is, you have considered greater than 0. So -x will be,
Ma'am, minus x is going to be minus x only.
I mean, the condition
It's,
minus
it's
x will
greater,
be,
is less than 0.
right? Lesser
Less
than or
than or
equal to.
equal to 0, yeah.
So firstly, you will say that this will be lesser than or equal to 0 only in the case when x is greater than or equal to 0, right? Firstly, I have
Yes,
just considered the
yes.
point which is for the differentiable function. I have found out a particular condition which can make it lesser than or equal to 0. I need to prove that it is quasi-concave. So for quasi-concavity, I need to pick any 2 points. I need to find out the value of function in order to use that correspondence theorem. If I substitute x1 as -2 and x2 as 3,
Yes.
okay. If I'm putting two values, what will be my f -2 and f3?
Ma'am, over here, x, what is x1 and what are 2 points here? The
You
two,
remember
what are pairs?
those, you remember when we have to prove quasi-concave or
Oh,
quasi-convex,
okay,
we
okay,
prove
yes.
Hill.
समझ गया, ma'am.
Yeah.
Two values of
हाँ,
x is what we are taking here.
हाँ. And then what will be the function's value?
Ma'am, so it's gonna be 1 second. Ma'am, for it, so इसमें हो जाएगा -2 only, -2 and 3. -2 and
Then
-3.
-3. And then if you consider any t, which is 0
Ma'am,
to
over
1
here, since it's quasi-concave, we need to find the max. No, we need to find the 1 second. No, we
minima.
need to find the minimum of fx and fy.
Correct.
So it is going to be -3.
So you will firstly write t -2 plus 1 minus t into 3, right?
Yes,
And then what? So it is x1 t 1 minus t x2, right? And you will prove that minimum of f -2 and f -3 is what?
-3.
-3. And if you find out fxt, using any value, that will always be greater than -3.
Greater than -3. Yes, therefore it is
Quasi-concave.
quasi-concave.
Okay. This is one way of doing it
Nice.
when you are assuming a function. But what if you hardly could remember there what function I could have taken? Then all those
Yes, ma'am,
stories
because
you will.
because over here we took two arbitrary points.
Correct. So in that case, take the help of theorems. For example, because you have to firstly find out the constraint, and then you need to prove whether function is quasi-concave or not. Of course, you have to show that so it is quasi-concave. It is not check whether. So you will say if x is greater than 0. Question has given you this is the bit, right? X
Yeah.
quasi-concave. So if x is greater than 0, what does it mean? X is greater than 0, then function is decreasing for positive x. This is what question is saying, right? Because this is the given condition,
Hmm. Yeah.
right? Because slope and its product with x is lesser than 0. And if x is greater, it is for greater. So if x is lesser than 0, it will be opposite, right? That is function is
Yeah.
increasing.
Function is increasing for for negative values of x.
Correct. When does it happen? That function is increasing when you are having lesser number of x and decreasing when you have more values of x, I mean positive values of x.
Ma'am, when x is in the denominator,
I mean, don't you think that it is how Hill works? It will be a downward thing. You will say that because function is increasing as you move away from the 0, from the origin, and decreasing
oh
when you
no,
are,
what I said was very dumb. When x is in the denominator,
I mean,
no,
that
yes,
is because fraction was not given, no? I need to relate
yeah,
everything with quasi-concavity. So you will interpret that if this condition is given, that means the function is this way, and this is how Hill works, and Hill works according to quasi-concave. So if you now state that theorem, if you consider any 2 points and the function's value at any point which is between them on the straight path is not less than the minima, then it is quasi-concave. You will write as if it is linear combination, right? Which has to be great. I mean, that condition of quasi-concavity,
hmm, fx(x2).
say that because the function never dips down the below the lower level, it has always an upper contour. So what you are doing, it is quasi-concave. You will start with the behavior of fx, that what is actually happening. Uh, that if you are moving, if it is x less, this condition, you will take the help of this. If x is lesser than 0, then f is going up. If x is greater than 0, then slopes, then it is going down. And it has peak at 0 if you put equal to. So that is the condition for Hill. If something is decreasing by increasing in the values, that is the function, that is the feature of quasi-concavity. Is this fine?
Yes, ma'am. I'll
Yes.
go through this today.